question for you. Take a look at this. Take a look at that shape. That's a little different than what you're used to seeing, right? You're used to seeing rectangles. That's a little bit different. Okay, that's not a rectangle. Is it?
No, sir.
Okay, that's not a rectangle. How do you know that's not a rectangle? Molly?
It doesn't have two long sides, the same size, and two short sides, the same size.
Okay, we're going to learn later on in geometry that a rectangle doesn't necessarily have to have two long sides and two short sides, because a square could also be a rectangle, but that's for a whole other lesson. But you're right, I do understand what you're saying.
It would be a big rectangle.
Mm-hmm.
If you put a line through here.
Well, that's my question. I will ask the question, is this a rectangle? How many people, raise your hand, if you think this is a rectangle, raise your hand. How many people think this is not a rectangle? Raise your hand. Very good. This is not a rectangle.
I know.
Okay, rectangles have 4 sides. This does not have 4 sides, which I'm sure many of you already knew that.
If you cut off, if you put a line right here, this right here would be a rectangle.
Well, we'll see about that. Now take a look at the question down here. If I were to give each group 2 tickets for each square unit of this figure, how many tickets would your group get? What if I did give you all those tickets, whoever figured this out? If you're working in groups, think you'd like to do that?
Yeah.
Okay, well I'm going to teach you how to do that. And you will figure this out, and I just might give you those tickets. We shall see. Go ahead and erase that. What happens if I do something like this? Put your the cap on your marker. Put marker down. I want to know. And you're going to discuss with your table mates there. And you can, Preston, you can move right back there. What do you do in a situation like this? Is this a rectangle?
No.
This is not a rectangle. Not 4 sides. It's just a shape. It's a polygon, which you'll learn later on in geometry. Now, this right here, if I asked you, we wanted to find the area of this, several things that we could do.
I need a picture.
Okay? If I want to know the area of this, what's probably the most obvious thing to do? The most obvious thing to do might be to what? What do you think, Drew? You could count. You could count. To me, that would be the most obvious thing to do, is to count up each individual square unit. Okay? Could you do that with this one?
Yes.
Yeah, you could. What if, I don't know, what if I had a rectangle, what if each one of these right here was split into, 1,000 of those little squares? Would that make it more difficult to count them up? Yes. Counting absolutely works, and for this, I may even suggest, let's count them. But sometimes that's not as efficient as we would want to be.
Yeah.
So I'm going to show you something that we could do, and actually, Kaylin kind of told us what she would have done, which is exactly what we're learning today. Okay, what are we doing today? Yeah, we're decomposing figures into rectangles. Now, because we dealt with rectangles, we know how to find the area of rectangles. So if we decompose this figure into rectangles, then it makes it easier to work with. Why are we doing that? To find the area of the figures. We want to find the area of those figures by decomposing. Well, there's a big word. What does decompose mean? What does decompose mean? Fisher? Break apart. To break apart, which, we talked about it in science. When things decompose, they break apart into smaller pieces. in math, when we decompose a figure, we break it up into smaller pieces. Actually, we've done decomposition in math this year. Y'all remember doing that? Well, you have if.
I remember the multiplication where we broke up the bigger number to try to figure out it.
Yes. What is that called? What property is that?
Distributive property.
Very good. That's the distributive property. We decompose big numbers to make it easier. Well, we can do that with figures also, and that's what we're about to do. So if you look at this, we want to be able to split this up into more than one rectangle, because right now it's not a rectangle.
Tickets.
Yes, the one with the tickets. We're going back to, you can put that right there. We're going back to this problem that we had at the very beginning, the one about the tickets. Okay, if you remember, that's the problem. If I were to give you groups of 2 tickets for each square unit of this figure, for how many tickets, or how many tickets would your group get? So, what I need you to do right now when I hand this out, I want you to discuss with your group how you would go about figuring this answer out. Okay? Discuss this with your group. How are you going to figure this out? Okay? Don't just hurry and work it on your own. Talk with your group. I'm going to give you a couple of minutes to work this out.
We're going to give each group 2 tickets for each
Talking with the group.
of this figure. How many tickets are we supposed to split and do
Talk to your group. Talk to your partner there.
split it right here? Do we write it?
Yes, work it out.
7 times 3 equals 21, and then 4 times 3 equals 12. Okay, and then 21 plus 12 equals 12. 3 equals 33. Okay. If I were given to give each group 2 tickets for each square unit of this figure, how many tickets would your group get? Okay, put at the bottom of the sentence. Your group would get blank tickets. Okay. There is. Paul, put your thing at the bottom. Put your sentence. Your group would get blank tickets. Okay, first we gotta find out how many groups there was. So 33 times what is it? 36.
Why would it be 33 times 2? Did that make sense?
Yes.
Absolutely. Good job.
Your group will get 66 tickets. Units that are times 2. It's right here. How much 4 times 4 equals 12. And then sometimes 3 is 21. Add those together. There's 2 classes. Aren't you going to put mine right here? You said why don't you put a line? Yeah, that's a good idea. Each. That's what 2 tickets for each square unit. There's 33. So you there's 30 that by 2. There's 33 square units. So 4 times 3 equals 12. And then 3 times 7 equals 21. So 21 and 12 equals 33. So 33 times 2 is a 2. For each square unit, these are the units. And these are the square units. So it's 66. I know, I put 65. Then times 2. Sentence. Your little boy did 66.
So the last thing that we're going to do is an exit ticket. We're just going to kind of close the lesson down. I want to see if you really do understand decomposing your figures into rectangles so that you can find the area of something that is not a rectangle. Haley, I want you to pass out the exit ticket. When the last exit ticket is passed out, you're going to have 3 minutes. Make sure your name is on it. Make sure your number is on it. Sure. Make sure your name is on it. Make sure your number is on it. You are on it. All right, Haley. Now, when you finish this, where is it going to go?
Exit ticket.
The exit ticket basket. I will check them and I'll let you know how you did.
Here.
Does everybody have one?
I don't have one.
Here. Haley, get back to the desk.
Can we start? No.
Make sure your name and number is on it. You have 3 minutes, and your 3 minutes starts now. When you're done, make sure it goes in the exit ticket basket, and I want you to get your science out. Get your science out, Haley.